Welcome back everyone to part 2 of the Pandas series discussion, where we're going to discuss some operations. Let's head back to that same Jupyter notebook from the previous lecture. Here I am back in that same Jupyter notebook from the previous lecture. As a quick note, the notebook that we're referring to is the first notebook here under the Pandas folder. It's called 00-series, and if you open up that notebook, you can go ahead and scroll down to where we begin discussing the key ideas of a series, such as a named index. And what I'm going to do is I'm going to copy the input for cell number 32 in that notebook, which is essentially just 2 dictionaries. And these dictionaries are essentially imaginary sales data for the first quarter of a company and the second quarter of a company. So it's just to easily create 2 series objects from a dictionary, save ourselves a little bit of typing by just copying and pasting this from the lecture notebook. And then what we're going to do here is we're going to convert this into a Pandas series. As we discussed earlier, I can just create a variable name and then say PD series, and we'll pass in this dictionary Q1, and let's say sales Q2 is equal to PD.series Q2. Again, remember it's capital S there. And so what I have here for sales Q1 is this Pandas series, where I have a labeled index of a country, Japan, China, India, USA, and then let's say the sales values for those particular countries in, let's say, quarter 1. And if we check out quarter 2, sales Q2, then I have sales for the second quarter of this imaginary company, Brazil, China, India, USA. So again, a couple of things to notice here is I can, as before, grab items based off the label index. So I can say, okay, sales Q1, what's going on, let's say for the country of Japan. I run this and it tells me my sales for Q1 were $80. Or I can also do this based off a numeric location. So if I somehow knew I wanted the very first item in that series, I would say 0 and returns back 80. Obviously, it's a lot more clear if we start using that labeled index, what 80 actually represents here. So I would encourage you to set up your data in a way where if you're doing some sort of grabbing of data, you try to use a named index so it's clear when you review your code or send your code to someone else, they can easily read it. This is a lot more readable than just passing in 0. And something to keep in mind, a super common mistake is accidentally passing in the wrong key here. So the key has to be exactly what the key is inside the actual series. So if you were to lowercase this to Japan, it's going to say there's a key error because it's key sensitive or it's case sensitive. So you'll notice here lowercase j doesn't work, or even if you do something which is a really common error of accidentally having, for example, an extra space. So if we say Japan, accidentally put an extra space there, it'll say key error Japan. So just keep that in mind. If you actually want to see what keys are available to you inside a series, because maybe you're having trouble actually finding it, you can say sales Q1 or whatever the name of your series is, and say keys, open and close parentheses, and then it's actually going to return back this index object, which is your index objects in order. So we can see that here. Okay, so this was one really easy way of finding out, oh, what's the exact string for whatever I'm looking for. Okay, so we know how to grab the keys and we know how to grab stuff based off the keys. Let's go ahead and discuss the very basics of operations between 2 series. So what's really nice about Pandas series objects is because they're built off a NumPy array, then we can actually perform broadcasted operations on them. So recall if I have a list such as 1, 2, and if I were to try to multiply everything in that list by 2, we already know something like this doesn't work. Because what it's going to do is essentially going to double up that list, when really what I want to do is multiply each item in that list by 2. However, we do know that if it's a NumPy array, this operation gets broadcasted, and then it gives us the results we expected, 2 and 4. And luckily, since a Pandas series is built off a NumPy array, then the same happens here. If I say sales Q1, it's going to report it back by the broadcasted operation, which means we can do stuff like start easily getting things, maybe we want to divide by 100 or something like that to get it into some sort of percentage format. And we can easily do that within a Pandas series itself. So you can broadcast these sort of operations. And what's nice is because we have a labeled index, when we perform operations between 2 series, it's actually going to take the labeled index into account. So what do I actually mean by that? We see that I have sales Q1, Japan, China, India, and USA. And if we take a look at this company's second quarter sales, you'll notice it says Brazil, China, India, USA. So what's actually happening here is we have information on Japan in Q1, but not in Q2. Instead, it got replaced by Brazil. So what happens if I'm trying to calculate my total sales for the first half of the year? Essentially, I want to say sales Q1 plus sales Q2. Well, if I say sales Q1 plus sales Q2, and I run this, by default, Pandas is going to be smart enough and match things up based off their labeled index. However, it's technically not smart enough to know what it should do in the case of the labeled indices not being present in both series or the multiple series you're adding up together. So instead of replacing it with a value, it will actually show you not a number and not a number for Japan. And this is actually a good way of Pandas essentially telling you, hey, Brazil and Japan are not present in both these series. Now let's say you, as the user, actually know that to be the case, and you want to fill in some value by default when it's not present in the series. Essentially, for example, you want Brazil in Q2 to be 100, and in theory, you want Brazil in Q1 to be 0. That way, this actually shows up as 100 when you add them together, and Japan shows up as 80 when you add them together. So while this is nice, that Pandas warns you, hey, Brazil and Japan aren't present in both these series, let's say after adjusting our evaluation, we say, that's okay, I need them to be filled in of some value. Well, to do that, we say sales Q1, and then what we're going to do is we call the add method on it. So we no longer use Python's base operators. Instead, we're going to have to call add. And if you do tab here, there's going to be a list of operations. So for example, if you wanted to do some sort of multiplication, it's going to be MUL or multiply. So keep that in mind. If you wanted to do division in this sort of format, it's going to be div or divide. You'll notice there's kind of two names here which do the same thing. So one's a little shorter than the other, but we want to add them. So I want to say sales Q1 added to the series sales Q2. So in parentheses with this method call, it says, hey, what's the other thing you want to add in here? And then it also takes in a fill value. So we'll say sales Q2, go ahead and add it. And then if we see what does that actual fill value represent, I scroll down here and it says the fill value is what you should fill in for existing missing values. So essentially, what are you going to fill in for Brazil and Japan if they're not present in both series? And in this case, a reasonable fill value is 0, since we made 0 sales for whatever quarter they're not present in. And now I can say fill value is 0, I run this, and I get back the results I want. I see Brazil is now 100 and Japan is 80. The last thing I want to point out here before we finish off this lecture is you'll notice that my original values were in integers. In general, as soon as you start doing numeric computations with any objects within Pandas, it's going to quickly convert them into floating point numbers. So it's just something to keep in mind. You can always specify the data type or change the data type of a Pandas series as you go along. In fact, it's one of its attributes you can access by saying dtype. And the original one you can see is integer 64. But if I say first half is equal to sales Q1 added to sales Q2, and then check the integer type, or excuse me, the data type there. So first half dtype, you'll notice now it's a floating point number. It's just something to keep in mind. Typically for our operations, we're not going to be concerned with things being transformed from an integer to a float because the math is still going to work out to our favor. It doesn't matter if we have 1 or 1.0. So throughout the course, we're not going to worry about this. But if you have a situation where you need them to be integers, you can always either round them off using np.round or pandas round, or you can just specify or hard code the data type in your operations to be whatever you're looking for, 64-bit integer or 64-bit float, and so on. And in fact, if we look back up to pd.series, or if we just call it here, pd.series, there's data index and there's also data type. So you can actually specify the data type for this series. And if you want, you can also name this series, which is just going to be a name that's kind of this high-level label for this series overall. All right, so that's the very basics of a Pandas series. Main thing to note here is that when you perform operations with two series, Pandas is going to be smart enough to understand that they're labeled and that they should perform the operation on the labels. However, if you have a special case where you don't want null values and instead you want them filled in with something, you'll have to call these special method calls. Okay, up next is data frames. I'll see you there.